Now we're recording. There's something else I needed to hit there. What was it? The recordings will be online. That being said, if you're going to rely on the recordings, make note, we have a quiz every day. Make sure it's done before class. To do right after class, so if you're in the online section, you can probably get away with kind of doing that during class the next day, but don't do that. It's a bad idea. I might make it so you can't do that. So, but we'll talk about that kind of logistical stuff later. For now, let's actually just kind of jump into this little bit of an intro I have, talking about what we're going to talk about in this class. So you think probably programming languages, that means we're going to like learn a whole bunch of languages, right? No, we're not going to do that. We're going to be talking mostly about the theory behind the programming languages you guys use. Particularly, we're going to study a class of languages called functional programming languages. I'll talk about this a little bit later, but these are languages where instead of writing loops and commands in sequence, in that sequential imperative style, we're going to actually write programs using functions as kind of the main object that we worry about. We'll get into that later. But first off, we're going to kind of survey this idea of what a formal system or a language is. I'll use those kind of interchangeably. So a formal system is usually just a more locked down programming language. It's something that's a little bit more tailored typically, but we often talk about programming languages as formal systems. So here, the first formal system you guys actually probably ever learned as kids was how to count, right? How do we count? When you first learned how to count, how did you do it? Go ahead. With your hands, right? Hands, and maybe if you were really smart, you figured out your toes work just as well, right? Toes are harder because you can't quite like keep them all like down. For those online, I'm like counting with my hands right now. And so we kind of evolved to learn to count with our toes. Now, why, or toes and hands? Probably mostly our hands. Toes are kind of hard to get to. Now that works great, except that as soon as I like move my hands in another way, I've lost my tally, right? So what did we invent instead to keep track of things over time when we were counting? Right after we started using our hands, before we had numerals and digits and stuff like that, what did we use? In between hands and say like your Roman numerals. Yeah. So draw lines, right? So tally marks, right? I kind of led you to it earlier. So we use tallies. So if I say I have, like, say I'm a goat farmer, goat herder, a shepherd, something like that. I guess those are all the same word. At the beginning of the day, I let all my goats out to pasture, right? And I count them. And I say I have a rock or something that makes easy tally marks. And I count them like that, 1 goat, 2 goats leaving, 4 goats are gone, 5 goats are gone. Let's say I have 7 goats. All 7 goats left at the beginning of the day. Now, at the end of the day, when my goats come back, the great thing about this system is if I want to make sure all my goats come home at the end of the day, I can just kind of remove a tally mark at a time. So say 2 goats come back, a 3rd goat came back, all the way down until, oh no, one of the goats didn't come back, right? And then I can go look for my goats. Or on a good day, they all come back, so no more tallies, right? First question I have for you guys about this system is, what's good, what's bad about the way I'm using tally marks right now? Yeah. Right, so they're not grouped together. They're kind of hard to get a quick count of. You don't have a quick intuition for what number of goats I have. Yeah.
It only works for low numbers.
Yeah, it only works for small numbers. It's kind of the same idea, right? Is this representation of numbers, it's like good for really small things. Basically, the same idea as with your hands. It counts about the same amount of stuff, except you have this nice, like, it's permanent over time, right? So you have some safety with respect to time. But let's say I want to make it easier to read. What do we do next? What's the next logical improvement? And for those of you online, feel free to say something in chat too. I can read those off as well. So And if you guys see someone say in chat, it should pop up over there too. But what's like the first logical thing we could do to clean this up a little bit? Yeah.
How we did it in elementary school, the fifth one was
yeah, it was like crossed out, right? So instead, we could do 1, 2, 3, 4, and then we group them into 5. And then we have 2 more, right? And all the nice features we had earlier are still present here, right? Except now we can count them by 5s a lot faster. So if you have a larger group, now you only need to count sets of 5. And if you can do multiplication kind of fast, you can figure out how many goats are gone or here really fast that way, right? What questions do I have about these guys now? So now let's push the goat thing a little farther, right? What happens if my buddy comes over and he brings his 6 goats? And we need to keep track of the whole herd. Like say he sells me 6 goats. How do I add those 6 goats into like my group? How do we combine them? So say he has, even if we use his numbers, so 1, 2, 3, 4, 5, and 1 more. How do we combine those groups? Yeah. Yeah, you add them. And how easy is addition with this system? Pretty easy, right? So all I do to add these things together is I take the groupings of 5, so these 2 groupings here, and I add them to the bottom. So I just kind of move them over. And then for the rest, I just bunch them all together. So you bunch kind of like with like. And if you have a new group of 5, then you just create another tally. But the idea is you just push them together. Really easy addition. You don't need to do anything special. Actually, this is quite a lot easier than numerals we typically use, right? Actually for adding. But now, where does this system kind of hit a wall? Let's say I'm a really successful goat farmer. What problem do I run into pretty quickly? Yeah. Well, multiplication's hard, right? But even the notion of multiplication in this system doesn't quite come up yet. I like where you're going. That question will be applicable in a minute, or that answer will be. Right, so every goat has their own tally mark in this system, right? So there's like this really heavy weight if I'm really successful goat farmer. I'm making a lot of tally marks. So where does this system evolve if I start to become a successful goat farmer? Yeah.
And my guess is like every group of 5 gets 1 tally.
Right, so every group of 5 gets 1 tally or 1 symbol, right? So 1 whatever it is, because we still want the idea of a single goat represented. We don't want to have a more coarse, kind of less precise symbolism, although that might be how it started. Actually, that's a pretty good, actually, no, that is how it started, because back in the day, we'd measure the number of cows you had by the hectare, which I believe was 600, or it was approximate though, it wasn't a precise amount. It was like this idea where it's like, oh, it's a lot, but it was a precise amount of a lot. You don't usually quantify the word a lot, but here we do. Yeah, so we introduce a new symbol. So let's say let's group them by 5s, right? So what's the symbol we introduce for that crossed out group? So for instance, here I've got 5. I want to represent this by a single symbol. Don't like that color though. What could I write that as? Maybe you're a Roman goat herder. Does that give anyone a hint? Yeah. A V, right? The Roman numeral for 5. Now, I don't believe this is like true historically, but does anyone have an idea of kind of maybe where the V and 5 came from? I think this is only true after the fact, but I don't think this is actually historically true. But if you note what happens here, that's about a V. I don't think that's actually where it comes from, so don't hold me to that, but it's a handy, like, kind of neat. I don't know if it's true, but it's kind of neat. Yeah, so we could represent this whole thing as 5, 5, and 3, like so. Ooh, I forgot to ask my favorite question about the last system. I'll get to it later though. So in this new system that we've devised, what are our symbols that we have in the system? This is a question I'll ask a lot in this class. What are the symbols involved? Yeah, V and a tally, right? So the V's are symbols. We'll actually make a little chart over here. Symbols. We have 1 and we have the V. Now, again, let's say I'm a successful goat herder. How do we continue to simplify this system? 2 V's are an X, right? And then, as we all know, we do this weird subtraction thing later where we have like the I in front of the V, and that gives us numbers like 4. So this is equal to our, what, 13? And then, but this is equal to our 4. You know, so there's this weird like prepending system that we use sometimes too, which is kind of a bastardization of what the system actually did really well. So the Romans kind of made it more confusing than it needed to be. But this, in the same way, if you think about it, that's a lot easier than writing that. That's kind of messy. We start to run into the same problem. So at most, we ever want 2 symbols to represent any kind of quantity is kind of our goal. And of course, that starts to break down. So for those of you that don't know, we then get L for 50, we get C for 100, and M for 1,000. I believe there's one more. There might be a D for 10 or for 5. I think it goes up to 10,000 if I remember right. Either way, for our purposes, that doesn't matter a whole lot. Now, what are the rules in this system for like adding stuff together or multiplying? Is it the same or easier than the system? Same, harder, easier than the system we had before? Can I just combine stuff by pushing it together anymore? Not really. So I kind of can, but then I have to do this big simplification step where I like kind of merge everything into new symbols. And like, let's not even talk about subtraction. Like it's harder now for sure, because you're like moving all these symbols around all the time. Oh, thank you for that. So Rose from online says D is 500. I think I said 5,000 earlier. D is 500. Yeah, so it's every 5 and 10, every increment of 5 and 10, or multiple of 5 and, not multiple, but every, is that power? I guess that'd be power to the 10 of 5 and 10, something like that. Yeah, so the general rules for the system are similar, but it has this big simplification step that we have now, right? So it's a little bit more complicated. What's the fact about the system that makes it easier to use? What was the big innovation that happened here? Any ideas? What makes this system better than just using our fingers or tally marks? Yeah. I can count quicker, I can count higher, but what's the mechanism that allows me to do that? So, sort of. I'm thinking more syntactically, what, from a perspective of a person designing a language, right? Because this is just a language for counting stuff, a system for counting stuff. What allows me to count higher and faster using this system versus the tally marks? Yeah.
So if you had like 49, it would just be like IL.
Right, versus 49 tally marks. So it's using a single symbol to represent more than one thing, which is the big innovation. So one symbol equals more than one goat, right? Makes counting a lot faster. It allowed for, bureaucracies to form in ancient Rome, right? You could have people that counted every goat in a province, and that's a pretty big deal. Now you can start taxing people. And the libertarians inside to start to die a little bit, right? Yeah, and bunch of similar answers from online with chat. Chat, I promise I will get better at reading your responses faster. Symbols to represent numbers. Large numbers can be written as a single symbol. Yeah, and it's by magnitude, which is really important. It's not this linear growth anymore. It's by orders of magnitude. Now, what happens to this system? Where are the pitfalls here? Where could this system get better? I'll give you a hint. There's a reason we don't use this system anymore. Yeah.
Would eventually run out of symbols or?
You'd run out of symbols, right? So let's say I have 1 million. The Romans did not have I don't believe, a symbol for 1 million. Chat says, and I really like this answer. What happens if I have 0 goats? Now that's an interesting thought. There's no idea of 0 in this system either. I believe the Romans had a notion of 0, but instead of using a symbol to represent nothing, they would actually usually explicitly say they had nothing. They didn't represent this within the formal system. So it's just used for counting purposes. And if you hit 0 or you have a negative number, SOL, you can't do it, right? So there's another point I had. Maybe not. So now what do we do? How do we improve this system further? Well, to do that, we have to leave the Roman Empire now, and we go down to, does anyone have a guess what area of the world we go to? No, not quite. A little farther east. The Middle East, still not quite, interestingly enough. So this is something not many people know, but so what we call the Arabic numeral system is actually called properly the Hindu Arabic system, because it didn't come from Arabia, but it came to Europe through Arabia. So this weird historical kind of problem. There's a really good book on this called, I believe it's In Search of Zero, or The Search for Zero. And this guy, a fairly notable mathematician, actually went on this like world tour to figure out where 0 first kind of popped out. And he actually traced it down to, I believe somewhere in Myanmar is the oldest recorded version of 0. It's on like this pot that almost got destroyed by some rebels. It's this wild, like Indiana Jones story. But anyway, so the Hindu Arabic system. What are the innovations here? How do we use it? So this is the system we use, where we use placeholders. This is the idea of 0. So instead of saying up here we have 13, instead of saying what would be x111, we instead introduce the placeholder. So this is the ones place, this is the tens place. And we say we have one set of 10, or 1x, and here we have 3 single things, ones, right? 3 ones, 1 10. And now you can start to do addition in a slightly different way. So now you do have to memorize some stuff. So what is 3 and 7? Well, you have to know what 7 means. So in our heads, we know that this is just, for instance, for the symbol 2, we know this is like 2 things. For the symbol 4, well, we know that's 4 things. And we have this intuition in our heads. It's built in. We've assigned to that symbol the meaning of how much stuff there is, right? We introduce 0 because what happens when you have 110 but no ones, right? So now the idea of having nothing actually plays a really big role, right? So to say 1 there and 0 there means 0 ones, and down here it says 110s. So now we finally worked our way up to about the first grade, right? Never did you guys ever think we'd be talking about counting in an upper level theory class in undergrad, right? Yes.
I believe the visuals, the representations of the numbers also were based on like how many quarters are in them, and the other quarters represent like what the number was. And so that's why 0 also has an quarter.
Oh, I didn't know that. That's interesting. That makes a lot of sense though.
There's like things like
Yeah, send that to me. I'd be very curious to see that. It makes sense though, because 4 kind of has 4 going on. Like it'd be even either way you write it, I guess it kind of has 4 points. 2 has 2. Well, 2 kind of has 3, doesn't it?
it's like this.
Okay, that.
Yeah, those 2 inner corners.
Oh, it's the number of inner corners. Yeah. Okay.
So you gotta like put a hat on a 7 and put the line. on a 7.
Oh, that would kind of do it. I'm intrigued by this. Now, interestingly enough, we haven't held all the numerals the same either, which makes it a little bit more complicated. So originally that might have been the case. It definitely is not with the numerals we use now. Yeah, for sure, very different in some cases, but also some numbers. 7 actually is one that looks, I believe, almost the same. It's like 7 and 3 and 5 have held remarkably similar all the way back to Southeast Asia, where all this kind of evolved, which is kind of neat. Okay, now my question is, and this is a question again, I'll ask all semester, and I'll write this down because this is a question you guys should make note of. So question 1, anytime we visit a formal system, I'm gonna ask these 2 questions, okay? 1, what are the symbols? Question 2, what are the rules or the meanings of the symbols? These are the 2 kind of core questions at when we're looking at a programming language or a formal system and wondering what it's all about. That's the question, the 2 questions we ask. It's like, what are the symbols? What are the rules? From that, you can figure out anything you need to know about the system, because that's all there is in the system, right? So it's this really good kind of reductive technique for getting at the core of something. When we design a language, we typically kind of break it down into 2 categories of topics, this kind of symbols and meanings. We have another word for this, and you guys have undoubtedly heard these 2 words before. I know I said one earlier. These words are, I'll use purple for definitions. Remind me that. We'll use purple for definitions. The symbols we call syntax. Dreaded syntax errors you had in that intro programming class, right? It's usually because you put a space somewhere or a semicolon somewhere it wasn't supposed to be, or you left it off, or you forgot an open bracket when you needed a closed bracket. These are our symbols. Next, what's the word for these rules or the meanings in a system? We call these the semantics of the system, or the language in this case. It's what it means. So when I say, what are the semantics of my tally system? Well, originally for our example, it was the number of goats I had, right? So there's both a meaning in how I added it together. That's kind of in the semantic domain, but also like, what do these numbers represent? You know, what's the meaning of them? It's my goats were going in and coming out, right? That was the literal kind of applied meaning. But then you could also have this kind of in between where it's like, okay, well, how do I deal with the thing as well? So addition, subtraction, these all live in the semantic domain typically. Symbols and syntax don't have any meaning on their own. This is an idea that will trip you guys up all semester, and we'll work to kind of beat that idea out of you. Is the syntax is just what you're looking at. It's mostly a design thing to make stuff easy to read, right? So syntax matters a lot, but it's not very often the interesting part of the system. So why is syntax important in our examples we just went over? Well, it let us count with much less headache, right? But note, as we decrease the amount of syntax or made it more concise, what did we have to do with the semantics? This is kind of that addition question. It got more difficult, right? So for addition, you have to start memorizing what the numerals all add up to. And if anyone's not convinced of that, you did memorize addition tables as a kid. I'm assuming. I don't know if anyone does like the three goats. Oh, that's 6 goats now. I don't think anyone actually does that in their head. That'd be just a big headache. So as we try and make more and more concise syntax, we get bigger semantics or more complex semantics in some cases. Turns out you can represent anything by 3 symbols and I think 4 semantic rules. You can represent anything you want, which is kind of neat. We'll talk about that way later when we cover the lambda calculus if we have time. And it's like provably that's the smallest system you can have, and it can represent anything you want. We don't do that though because it's a big headache to use that system. So we do other stuff to make this more and more convenient for us. And then out come languages like C, languages like Scala, the one we'll learn in this class, languages I like Haskell, which are super concise, or Lisp. These are really small, tightly packed languages with very few things to learn. And when you learn them, you just have all this kind of power because everything works on 3 or 4 principles. This is what we'll start to study this semester is, you know, when can we make these kind of reductions to make our systems much smaller, more expressive is a word we'll often talk about, is the expressivity of a system. So I'll add a bonus question we can often ask. So how expressive? 2 S's? 2 S's. We'll often talk about expressivity in a very loose, kind of undefined way, but you can also define it. So like if I want to write complicated program, how many symbols can I write that program in? Or how well does it kind of convey meaning to a person reading it? These are all kind of valid kind of trade-offs you talk about when defining a language. Oh, let's get back on my notes. I got a little off notes there. Expressing ideas. Yeah, so and something to make note, and this is something some of you might push back on a little bit, but the idea of a good what is a good programming language? Like have you and your friends ever argued about like what's the best language? Like, have you ever tried to get your friend to learn a programming language? You guys were not nerdy enough in high school then. Because me and my friends did. We were huge nerds, but you know, you try and get them to learn a new language, so you had somebody to learn the language with. But at the same time, you had to make the argument, oh, it's better for this and that reason. I guess this is what PL nerds do. In the lab, we're always kind of chatting about which language is better. It's kind of like just a team. Yeah, okay, so some people on chat are saying all the time, thank you. And there's some like, you know, joke languages that you learn for the fun of it, and they all have the same thing. I'm pretty sure someone posted a joke language in here just now. So, or the cheese language. There's one with a bunch of expletives I won't say in class, but you all know what I'm talking about. Or some of you do, I'm sure. Yeah, so, but anyway, expressivity is often this thing we talk about where it's like, how concise can you write a program? or also like how easy is it to write what you want to write? Is it difficult? Is it easy, hard? You know, like how many symbols does it take to just write the thing that you want to write? Because you can usually explain it in words really easily, right? It's like, oh, I need to do a program that, I don't know, adds these two databases together. I just described that in 6 words, and it would take thousands of lines of C-level code for most database people to implement a system like that. Now they implement those systems and then write a language like SQL, and you can just do it. You know, you just combine 2 tables. It's like super easy to do, but it's because somebody did a lot of work under the hood to make that language happen, right? Let's see. Yeah, so the aim also, will always aim, make better, easier to read programs. That's actually something we'll teach you when we learn how to do functional programming, is we actually aim for these really tight, small programs. And you can read it and understand exactly what it does just by glancing at it. It's really cool when you finally catch on, you're like, oh, I get what this is doing. Other areas, functional programming and Scala. So that's what I guess that's what I've just been soapboxing about for a few minutes. Semantics and interpreters. So when we design a new formal system, we want to write a program that can take some syntax and run the program, right? That's what we'll mostly focus on. These little programs that run a program we'll call interpreters. They're a little different than compilers. Does anyone offhand know the difference or have a guess? Interpreter versus compiler. Yes.
Just a guess. I thought it was like the interpreters with like makes it into machine code.
Other way around. Yeah. So instead, the interpreters are going to just run the program, give us a result right there, then and there. The compilers actually run a whole bunch of, typically they'll run efficiency kind of stuff and make it faster, run it at the machine code level. Whereas our interpreters are going to typically run it at usually at a higher level. Usually at the level of another interpreter, which is kind of a weird kind of mental gymnastics, but it's kind of running it at the runtime level, even though you're running a program, instead of compiling it down to machine code. Eventually it gets compiled down to machine code, but that's somewhere else, right? And that's a different class. So we won't talk a whole lot about compilers in this class. And I'm not the person you want to necessarily learn that from. There are people here that teach that though. We'll learn about a little bit about control flow, about this really cool idea called type theory. Actually, we'll talk about type theory a lot because I'm a type theorist, and a lot of this can be approached from that direction. So giving things types all the time. We like that, especially when we do the functional programming stuff. And then we'll have time for some advanced topics as well, time permitting, but we always have time in a summer class. So that might cover dependent types. What else? Differentiable programming, probabilistic programming, things like that. Just other topics in the PL umbrella. They're a little bit more fun. So let's see. Okay, now we get to jump onto the boring stuff. But first, any questions about that little intro to counting thing we just did? Questions about how that all ties together? Or there's a lot to throw at you. You know, how to count in, I guess, 35 minutes is pretty tough, right? This is why there's a joke whenever like you try to formalize mathematics, it takes like 100 or 200 pages to get to the point where you can add numbers together. This is why. It's like there's all this other stuff that happens under the hood that nobody really knows about. You'll often hear that adage. There's a book called Principia Mathematica, not the one Newton wrote. This one's by Bertrand Russell and Alfred White Northhead, who are two of like the heavy hitting logicians of yesteryear. And they wrote this book, and there's all this stuff about how it's incomplete. Maybe if you've heard of Gödel's incompleteness theorem. There's a really good book called Gödel, Escher, Bach about formal systems. Influences a lot of how I teach this class, but really good read on its own. It's just like a novel, won a Pulitzer Prize, but it talks about how these systems are formalized and why it takes 35 minutes to teach how to count. So anyway, let's jump into the really boring stuff now. So let's just go over the syllabus kind of line by line. We'll cover that, and then we'll hopefully jump into some more material before we break for the day. My name's Jack. I said that earlier. Don't call me John. That's my dad's name. You can still email me at john.p.martin@colorado.edu, but please don't email me. My email's there mostly for you guys to schedule office hours outside of the normal time. We'll talk about that in a minute. But for most of your kind of course-related questions, you're going to post on Piazza. And Sakanya and I will be able to answer. We'll also have a CA for the class. And I believe we might have 2 CAs. 1 CA? I don't really remember. I should look that up. Sakanya is also grading your stuff. Most everything will be auto-graded because we're a good mix of an online and in-person class. And what else on there? We'll meet in ECES 114. If you're signed up for the online section, feel free to come in person. I doubt we'll ever be full in here. And if we are, we can kind of move stuff around and make it not full because there are a lot of chairs in here. Let's see. I'm looking at the wrong sheet. The time, yeah, so time for this class will be the same for the lectures. It'll always be at 5:05. That being said, for the recitations, you may be at a different time, so double check that. If you're in the online section for recitation, I defer to Sakanya about which one you attend. If she doesn't care about swapping, I don't, but ask her because she may care. So otherwise, I believe the second recitation is right after this scheduled time. So there's one during the normal time, except on Mondays, and there's one right after. So it goes pretty late. Yeah, feel free to email us, but try and keep it to logistics type stuff. Please, if you have a logistics question, you need to meet with us privately about accommodations. Do that stuff over email. Family stuff. You're going to be gone for a while. Let us know on there. Otherwise, if it's any kind of course-related question, post on Piazza. I don't know why I'm going to spend this much time explaining it. You guys all know this stuff. Feel free to interrupt with questions too. I don't mind. You guys don't need to raise your hand. Please don't raise your hands. If you're in class, if you're online, go ahead and just speak up. If we need to do a hand raising system for the online stuff, we can. But otherwise, just kind of speak up. It shouldn't be a problem. Interrupt me. I like to be interrupted. Sweet. So class meet. Oh, there's the breakdown for the class meeting sections. Check what your section is. Please go to that recitation for your first week. And then after that, we can determine what needs to be done swapping wise. Course paid, we are on Canvas. Pretty standard Canvas page. There's not a whole lot up there right now. There's just kind of a synopsis for week 1. Your first quiz is already online there. We'll talk about that. And the syllabus. There will be a lot more on there in the coming days. This semester, I've developed a lot of this coursework over time, but the writing is not quite there yet. So maybe doing a lot more kind of writing and exposition for you guys, just for outside reading. This semester is kind of the goal. So there should be a lot more writing up there. Main references, please don't purchase these textbooks necessarily. I won't refer to them very often, but they are handy resources. Primary reading I'll write and send out to you guys. That being said, it's not necessarily a replacement for the lecture over the summers. I do teach this a little bit different. Shuram, he sends out stuff at the beginning of each week. I won't necessarily, it'll be more during the week as we cover material. If writing is necessary, it won't always be. Otherwise, we have one textbook for learning how to program in Scala. That's the Odersky book. That's that third bullet point. And Essentials of Programming Languages, 3rd edition from Friedman and Wand. Friedman's kind of this huge figure in the PL community. He's a very good writer. And it's a very good textbook. That being said, you don't necessarily need it, but you should be able to get it online for free. Any questions so far? I'm kind of going through all this very fast. Yes. I'll get to that in a second. If I don't, remind me. Actually, I'll cover that now. Oh, and there was a question. Am I in the classroom and Zoom at the same time? Yes, I am. That will be the case every day. This is a hybrid class. So some of you will be online, some will be in person. Hopefully, the iPad is picking up most of what we're saying in the class. You'll always be able to hear me, but for the rest of the people in the class, it might be a little quiet. I'll try my best to repeat what anyone ever says, though. So, yeah, so office hours, I guess I'll address that now. It's the right part of the syllabus. So Kanya set hours and sent them to me earlier today. They looked good. So expect hers to be posted on Canvas later. I actually expect mine to be posted on Canvas later too. Still need to figure out when they are. They'll be probably twice a week in my case. And I think she had one larger block, if I remember right. And the CA will have a lot of hours because it's mostly what they're here for. It's just to kind of work through stuff with you guys. Those will be a mix of online and in person. I know when I hold them, I will always hold them kind of hybrid, just like we do class, where people can kind of listen in if you're online. The office hours that are listed, we'll try to keep to doing material kind of tutoring level stuff there. If you have private stuff, accommodations to talk about, email me and we'll set up a time. It's just better to kind of separate those two. I don't like how we mix them. We really ought not to. So yeah, do that for office hours. If you don't attend lecture and just come to office hours and ask a whole bunch of questions, I'll probably get a little ticked off. I mean, as any professor would. So please attend lecture. Don't just show up to office hours expecting free tutoring. It's not really what it's there for. It's there to just answer, clear up questions. So yeah, so mix, to answer your question, it is going to be a mix of online and in person for office hours. Questions about office hours? Does that sound good? And we're always pretty much available for, if you do need extra help, email us and we can set up some time. It's always going to be an option. If you can't make the scheduled times, email us and we can schedule something. I do not mind meeting outside of the normal hours. I guess a disclaimer now, that will be the case for the first month. I'm moving a little bit further up in the mountains in July, so I'll be commuting in 3 days a week, so it'll be a little tighter. It'll have to be Tuesday through Thursday, but otherwise, we can schedule stuff. So I guess that's office hours. Please read this nice long introduction on your own at some point. There's some interesting stuff there. Coursework. So this is approximate. I do reserve the right to change this a little bit. It won't be a whole lot. The biggest change that might occur is if I decide I want to put myself, the TA, and the CA through grading projects. We might do a project. I'm not sure how on the rails or off the rails that'll be. It might be for extra credit. I'm not sure yet. But I do reserve the right to kind of tweak the grading proportions if we want to do that. Largely is going to be determined by the amount of time we have. So for summer class, it's kind of hard to fit in a big project, but something small might pop up. Otherwise, we will have daily quizzes. So it'll be after anytime we have a lecture. That night we'll have a quiz. It'll be due the next day at the beginning. I think it's at the beginning of the lecture. It might be at the end. I think it might. Yeah, I don't remember what I said it to. Plan on it being the beginning of the next lecture, though. The idea of that is not to be overly difficult. You will not really have to look anything up unless you just missed something in class. So that's kind of the idea is for me to kind of grill into you guys the main idea of the class that day. That way we can do immediate feedback and talk about it the next day. For a summer class, everything's accelerated anyway. We don't have as many iterations to kind of get these ideas in your head. So the quiz is just one more kind of touch point for that. Seems like a lot. It won't really be that bad. 3 questions every day. Always will hopefully be multiple choice, probably. Maybe not, but for now it'll be multiple choice. 70% of the grade of those, as I'm sure you've read, is free. Just for answering the questions, all 3 of them, you get 70%. The other 30 is for correct answers. I think that's a fair mix. It gives you a bunch of padding points. Probably won't accept those late ever. It would take something pretty extreme to trigger that. Partially because it's a pain in the butt to grade these after the fact, or just to make sure all the grades are in. And it kind of defeats the purpose if you do these like 4 days later. It just doesn't really work. But it's also a fairly small part of the grade. So even if you just fill it out, like I said, that's 70%. You can miss days just as long as you fill the thing out. Yeah, for days after lectures, so Tuesday, Wednesday, Thursday, there'll be more theoretical questions. And then on Mondays, there'll be more coding based. So, and I'll talk about that in a second, about the kind of format of the week. Weekly problem sets. So every week we'll have a set of problems for you guys to do. That'll be in Scala programming, pretty much always programming. There will be a little bit of kind of stuff you have to type out, but not a whole lot. For the first couple weeks, there will be 2 problem sets a week, but they're smaller. So kind of goes along with the quiz thing, is we cover a lot in the first 3 weeks. That's more technical. And we have to iterate on that, of course, just to get those ideas ingrained. For those problem sets. So 2 of those a week. I think it should just be for the first 2, it might be the first 3 weeks. I think it's the first 3 weeks. And then after that, we just do 1 larger one every week. Shouldn't really take you more than a couple hours at most. They're not really that bad, as long as you're kind of grasping the concepts. Otherwise, it might be difficult, of course. So a few questions from chat. What about attendance? I won't be giving points for attendance, but that being said, if you don't attend the lecture, it'll make the quizzes hard to do. So the quizzes are the attendance, basically. I'm kind of using those as proxy. As long as you check in with the class once a day, that's attendance. The lectures will be recorded and put on Canvas. I don't necessarily love that, but we've been basically told we should. We're still in COVID times. I completely get, if you guys just want to watch and, fill out the quiz after the lecture time, that's fine. I get that. I've been a student for a very long time, and I'd be lying if I said I didn't watch a lot of my lectures after the fact. So there were a couple of questions online. Yeah, in chat, again, or online folks, feel free to ask questions on chat. I'll get to those very quickly. So weekly problem sets, midterm will be, I believe, after the 3rd week. So probably week 3, 4, at the end of week 3 or beginning of week 4. That's when we're done with the kind of how do we do functional programming stuff and move into more of the theory of programming languages. The class is pretty split between those 2 topics. So it'll seem, we'll use all the stuff in the first few weeks for the second set of the class, for the second kind of more programming language theory side. But it'll be to implement the ideas that we talk about there. So the functional programming stuff's really cool. I wish we could teach a whole class on it. It's my favorite thing about this class. But we have to keep it pretty tight because we have to talk about actual PL stuff. So that'll be after midterm, will encompass all the functional programming ideas, hopefully. And then the final, which will be comprehensive. Both of those are 20%. You have to do most of every bucket in order to pass the class. So obviously you could get 100% on the midterm, the weekly problem sets and the online quizzes, and just drop everything and get a B by the numbers, but you're not allowed to do that. You need to take the final to pass the class. Otherwise you'll get an incomplete. There's a blurb up top about that. Yeah, that's about all. Any more questions about kind of coursework, grades, stuff like that? They'll be online, open book. That stuff. There'll be questions that won't be, you can't just look them up. It will require some critical thinking. For the most part, there will be a few give me questions that you can probably find online. Yeah, open book. They won't be that bad. I don't want to write a hard final. I don't like doing that to you guys. So, let's see. So if there's no more questions about that, collaboration policy is pretty standard. Like, don't cheat, don't look up questions. I won't know if you do, but like, I trust you guys. You won't pass the final though if you do have to look up a bunch of stuff. It just won't be feasible to do it. So, and I'll know from your online quizzes if you're cheating. So please don't cheat. If you've gotten code from friends in the past, who have taken this class, the code will change a little bit. We'll also know for various reasons if you copy code blatantly, like we can pick up on it. We're PL people, we know what good code looks like and when it's been copied. Don't copy code. Yeah, you can talk about homework with everybody. Just don't do the problems for each other. Or if you have to, teach them into the solution or something like that. Yeah, and if there's any doubt about the collaboration policies on there, ask. It's going to be pretty lax as far as that goes. Class policy. So this is where we get into the fun stuff. So please make sure you're here every day. Obviously, I teach in this very back and forth style. If you don't get the back and forth style, then there's not a whole lot for me to do here other than give you reading to do. So please be here. Watching the lectures recorded won't be ideal for this class. Especially because if I miss something, it's hard for me to cover that if I'm not there with you. So no laptops or electronic stuff in class, which is okay today. Okay today. Just in class, I just like pen and paper. It's easier. I know what you guys are like. I can read the room better. It's just a personal thing. I teach better that way. So look at it that way. You guys are getting a product because you're on pen and paper. Think about it like that. The notes will be super easy. I won't be pulling up huge code listings in this class ever, which is awesome. I can do everything Blackboard typically. It'll be on the iPad though. So yeah, for those of you in the online section, feel free to take notes however you want. Just for people in class, just do pen and paper. Recitations are when you can bring your laptops in. Actually, please do bring your laptops in because you're going to be doing a lot of coding and recitation. So now, yeah, in the weekly format. So the days are wrong on here. So your recitations will be on Mondays with Sukanya. And you'll be doing the coding stuff. So learning how to actually do everything in Scala. I'll be teaching mostly the ideas in here. And then you'll take it and learn the syntax for it on Mondays, right? The hard part is all the semantics behind it. On Monday, you're just learning how to put this into the Scala language. The recitations will directly feed into the homework, so they're very related. If you complete the recitation, you should not have a hard time on the homework. Yeah, so that's on Mondays, Tuesday, Wednesday, Thursday. We cover theoretical stuff. Homework will be posted after recitation or before, probably that morning. You won't really be able to do it until after you do recitation. So, yeah, so your first homework, your first problem set won't be until Monday. I might put it out early for those of you that are interested, but otherwise, don't worry about that yet. Let's see. Any questions about policy stuff? Those kind of bullet points. There's a big list of topics. It's a little outdated. This is from 2 years ago, so some of that might change a little bit. We will cover object-oriented programming a little bit at some point, probably. That's something they want us to cover, but that's also a different class. So we'll cover more of it from the linguistic perspective. How is that different from what we're learning anyway? Because there is a pretty big difference between that and functional programming, but they're not incompatible. You'll often see languages like Scala marry the two in a really nice way. University policies, I think that's the standard stuff. I hope it's up to date. If it's not, forgive me. But normal, the don't be a dick policies, please. Like, don't be a dick. Be good in class. We'll have a good time. I love this subject matter. So if you guys keep me after class and we talk for hours about programming languages, we'll be friends. It'll be a fun time. I still have 20 minutes, so we can jump into real topics now. But we'll just introduce one. We'll let you guys go a few minutes early, but we'll introduce data types at a very high level first. So sweet. Oh, I can stay in there. Sweet, sweet, sweet. So a new page. Where's my Apple Pencil? Oh, I should ask first. Any questions about anything in the syllabus or anything I didn't cover that you guys would like to know about? Yes.
So the recitation will be in this room.
I believe the recitation is also in the room we are in now. There are online sections of the recitation as well. Again, try to attend if you can. It's just going to be better that way. Anything else? Someone asked, what questions do I have? What keeps me up at night? What questions do I have? Oh, so many. How to navigate graduate school is at the top of it. And what keeps me up at night? Graduate school. So there's your answer to that question. It's great, I promise. Otherwise, let's jump into the topics for the day. Algebraic data types. So this is our first topic. It's kind of at the core of everything else we're going to do in here. So this idea. What are data types? What is data? So in this class, we'll take kind of a different perspective towards what data types are, what types are. Now, you guys probably have a high level intuition of what a type is. What is a type? What's a type? Yeah, so it's a way of classifying things, a way of kind of grouping stuff together, maybe. I believe, and correct me if I'm wrong, discrete math was a prereq for this class, right? In discrete math, we talked about a certain theory of, does anyone remember? The way of doing math. I have exclusive member deals from Costco. We talked about the theory of sets, set theory. We talked about grouping things in these sets, and we can do stuff with sets. So like there are sets of numbers, sets of Boolean, and Booleans are a set, could be thought of as a set. So types are analogous to sets. So type is approximately set until you get to graduate level kind of computer science and mathematics, and those are actually different things. But for you guys' purposes, they're very similar ideas. Hence the approximate equal sign, not the actual equal sign. They're similar. So think about them as sets. What's kind of the simplest data type you could think of? Int's pretty simple. So yeah, so actually I'll pose that as a question. What are some types? So one is the integers. We typically write integers with this fancy Z shape. I won't shy away from mathematical notations. You'll see, you know, the fun math notation throughout the class. So does anyone know how to draw this Z shape? Anyone see how I just did it? This is just a handy dandy. It's way better than drawing, what is it, that? Is that how you usually draw it? I don't even remember. I haven't drawn it the other way in years. So to draw it this way, what you do is you make a 7, and then you make like a backward 7 like that. And then you kind of close it off, give it the little serifs because it looks cooler. Just a fun, like, I'm kind of a little bit of a penmanship notation nerd, so you'll get those fun little treats throughout the semester. That's how you draw that. So think 2 7s, that's how you draw the integer Z. What are some other sets we often talk about? Booleans. All right, so this is the first one we'll kind of discuss at length. Booleans, we often will write this with a fancy B. Now, I don't draw the really fancy one like this because it's hard to see. Yeah, but Booleans, what are some others? What about other sets of numbers? Let's talk about this for a second. Or go ahead. Double. So that's a particular kind typically that we'll see in kind of lower level machine languages, or languages that kind of target, kind of compile down to machine code. Doubles, or what's the general class that double falls into? Do you remember? Floats. Yeah, floating point numbers, right? That's not how you spell flipped. So that's another set. What are some other sets of numbers? What do we call the numbers that are the counting numbers with 0? Not the reals, because remember the reals, so the doubles and floating point approximate real numbers. Yeah, so chat just lit up. Natural numbers are the counting numbers, right? Natural or the whole numbers are the natural numbers, that's 0. We'll talk about nats a lot. So these are 0, 1, 2, and on. We'll write this with a fancy N. Chats also said, char, car, characters. There is a null type in some type theories, not in the one we'll talk, well, there sort of is in the one we'll talk about. So these are all kind of various types that we like to talk about, right? How do we encode these things though? If I want to like create a new type, how do we do that? So these are the definitions, the way we'll write these definitions in class. So we'll start with Booleans. And start by defining those. How do we define the Booleans? Well, what's in the set of Booleans? What are the items or the terms in a Boolean? Yes, just true and false. So yeah, chat's saying the same thing. So we got true and false. So how do we write this? So we're gonna use fancy symbol B, or I could also say bool down here. You know, you could say it either way. That part doesn't matter a whole lot. And then we'll write double colon equals. Now, what does double colon mean? It's a symbol, right? So I'm going to give it a nice little definition, a meaning, a semantics. So double colon up here, or I'll use purple because it said I'd use purple. And this is the no, ironically, it's the kind of definition of something new, right? So I'm saying that bools are defined as. So if I had A double colon equals B, A is defined as B. Okay. Okay. So now we said there is a true and a false in the Boolean. So we write that as, well, there's a term called true. And we give it a pipe symbol, or that up and down bar. And we read that as or. So it's either true or it's false. Okay, or it's the set. You could read that also as kind of an addition almost. I could say that's the set of true and false, right? So here, the or kind of means and as well, right? So when I'm talking about what's in the set, you read that as an and. When I'm talking about, okay, I have a Boolean, what is it? It's either true or false. It's not going to ever be both, but it's kind of with respect to how you're talking about it. I guess I could write it down here, true or false. Both of those definitions are the same. Again, different words can be defined to be the same thing. So here they just mean the same thing. So that's the type. Yeah, what are the parts of this definition? So here we have the name of the type. And then on the right-hand side of that definition, we'll have the constructors or the terms of that type. Okay. Check my notes. Okay, looking good. Have you guys ever seen a notation kind of similar to this before? Does anyone remember what it's called? I'm trying to think of what class you would have seen it. Maybe in an algorithms class, maybe.
Data structures or computer systems.
You might have seen it in data structures, something similar called Backus-Naur form, which is a way of describing languages. You'll often see it in language documents, and it'll use a lot of kind of angle braces instead. Same thing. They all describe the same thing at the end of the day. This is just the notation we'll use, kind of the bar and the constructors all put together. Sometimes I might write the same thing as, but in this form, so I could say the bools are defined as true, and I can put the bar down here, or false. I'll usually write it in this style. So you read it line by line instead. But that's all just kind of notation. That's not very interesting, just so you're not shocked by that. You might see both. So some more notation. If I have a term, say we have a variable x, and it's a Boolean, I can write x is of type Boolean. So this reads, I guess this is more in definition territory, x is of type Boolean. Okay. Is this new notation for anyone? You guys have all seen this before? Maybe? No? Maybe not. Yeah, so sometimes in some languages, you kind of put the type before the thing you're about to define. In others, you'll see it as after a colon. In this class, you'll always see it in this style. So x is of type B, or an element x of type B. You could also say, like, to say true of type B, like that's true as well. But to say like 5 of type Boolean, that's bad. We don't want to do that. We say this is ill-typed. Now it's getting ahead a little bit. We don't want to talk about typing a whole ton yet. That might be important though later. If you have something with the wrong type and say you annotate it in a program, it'll throw errors at you. So something to be aware of. Now, I think that's all I want to do today, is just kind of introduce that notation. So tomorrow we'll start talking about how functions come into play and how maybe we can write little, very small programs to manipulate true and false, the Booleans, and introduce variables a little bit and this kind of new functional programming style. So I guess just to recap, this is the introduction to what functional programming is we kind of start from these very basic data type definitions, write functions over those definitions, and you begin to have this really kind of beautiful space of programming start to open up just from these first principles. So any questions before we all bounce? Well, sweet. Well, have a good evening, guys, and I'll see you tomorrow. Don't forget to that quiz. I'll send out a reminder pretty quick on Canvas, but otherwise, have a great evening. Hopefully Canvas is online. Did anyone try and sign on to it? Yeah, okay, so it's there. Perfect. Okay, cool. So both online and in person can get to Canvas. That's good. So I'll send out announcements through there pretty much for the rest of the semester. Otherwise, have a good evening, guys. You're free to go. I'll hang around for a couple minutes if you have questions or anything to talk about.